Accelerating the pace of innovation with open ecosystems, pushing the boundaries of performance, driving the confidential computing revolution. Intel Software, pioneer the impossible. Increase your productivity and speed development cycles with open ecosystems that help break down barriers, build vibrant communities, and solve global challenges. Select your software and achieve optimized performance with cross-architecture, cross-vendor tools that give you the choice to run your workloads where you want. Build with confidence and develop on a foundation of trust with our comprehensive approach to software, data, and device security. Unlock value at every layer of the stack with Intel Software.
Welcome back to Innovation 2022. Please welcome Intel's Chief Technology Officer, Gregg Lavender.
Welcome to day 2 of Intel Innovation. I'm so glad to be here. As CTO, I represent really tens of thousands of engineers who are productively working across the company every day, 19,000 of which are software engineers, which often surprises people. The number of software engineers we have at Intel. It's always a hard act to follow Pat. He's so great, he's got so much energy. I'm more of a serious, like, get the job done geek who just like focuses on all the core technology. So I really want to sort of like, I'll try to smile more. Because I got a lot of really great things to tell you about. I've got some great people coming on stage. But I just want to really extend a warm welcome to everyone here today, physically, and those virtually. It's really my privilege to be the Day 2 Innovation speaker. An event by developers, for developers. And we're going to talk a lot about software, but also about the hardware and how the hardware and the software play together well to deliver the value that we can bring to the market across our entire portfolio. I said internally at Intel, I'm known as doing t-shirt reveals when I give all hands meetings, open forums, town halls, and Pat's co-opted my t-shirt stories, but with his his geek in binary. I just do something really simple, which is we're just open at Intel, right? We're open software, and we have choice and trust. And you'll see many people wearing these t-shirts around the company, and it's really our commitment to the ecosystem, and founded, as I said, on openness, choice, and trust. And I'm going to talk about that today. So as a developer for more than 25 years of my 35-year career, I got pushed into management because I realized I became the bottleneck for all the rest of my software engineers. I was just getting too slow at writing code and had to adopt modern DevOps technologies. So I just handed it off to the younger generation. And as we saw with RIA yesterday, we got a pretty brilliant set of younger generation people here at Intel coming up fast behind us. So Pat and I got to get a lot of things done so that we can retire and hand the company over to the younger generation. Much of my own professional development as a software engineer has really been about driving the value of, as a system architect. I was a research scientist at a university. I've been a demanding customer of Intel. I started programming the 8085 back when I was in high school. And if you remember, the CP/M operating system was sort of all we had back in those days. And then I graduated up to the Intel 8088, and finally my first job out of college was programming the 8086 and ASM 86 assembler. And so I've been using every Intel generation of processors since then, programming them, writing operating systems, networking code, et cetera. And so I've always had a love for Intel. I programmed all the other processor architectures of the day, particularly when I was at Sun Microsystems. But really, I keep coming back to the Intel innovation machine that can deliver this great technology. And given my depth of experience in both hardware and software systems engineering, I really, really enjoy being here, driving the software direction and new software strategy for the company. And so as we go forward, I understand the constraints faced by developers, whether it's related to performance, productivity, portability, and particularly quality. As everybody knows in the company by now, I'm a real stickler for quality. and we're not going to ship second-rate products. We're going to ship first-rate leading-edge products. So my job at Intel, my team and I are working hard to remove all the barriers that impede your ability as developers to maximize your productivity on our platforms. A global development survey recently conducted by the Evans Data Group in late 2021 revealed that 90% of the 25 million estimated developers globally are using software developed and or optimized by Intel, and only a fraction of them actually know it. We've done such a good job about being quiet about all the software innovations that we provide, not just at the firmware, the BIOS, the foundational layer of our software stack, but across the whole open source ecosystem that we've seeded all the optimization code across all major technologies, including working with our ISV commercial partners to make sure everything runs extremely well on our whole family of processors, CPUs, GPUs, and even our FPGAs. So in some sense, we've sort of overachieved, right? We've delivered tremendous value into the whole ecosystem, but we're not monetizing it. And I'll talk about how we're going to start to do that in a little bit. So today I want to spend a little bit of time talking about our software assets and the resources we have that are available to the developer ecosystem, and then geeking out through some pretty cool examples and live demos, not from me, but from some of my technical staff and some of our customers that showcase many of the technology innovations and how they're impacting the world and causing real change to happen, particularly in the AI ML space. And these are all built on this, what I said, call this sort of foundational open ecosystem approach based on choice and trust, and thereby catalyzing a larger ecosystem of people to be innovative, co-innovate, and create value for themselves, their customers, and their companies. So over time, this open approach towards software development and hardware standardizations, which we've all also driven, have proven to promote growth and innovation for others. And that's really the key of what we want to do, is to drive that demand through that demand cycle of those technologies pulling the value that we can deliver through our hardware and our software stacks. And this creates choice for developers, helping you maximize the value along with the trust that you need for your solutions. And I'll talk a bit about our confidential computing platforms and why it's so important now as we go into the future. The Linux kernel is just one example of the technologies that Intel has been contributing to for well over a decade of contributions into that open source community. You heard from Linus Torvalds yesterday, right? What a humble person to have created such magnitude of opportunity for innovation for everyone with the work and the leadership he's provided through the Linux Foundation and the Linux operating system. And it really took decades to get to that point. So Intel has always been this corporate contributor to the Linux kernel. And as I said, as Linus once said, that is what makes Linux so good, is that you put something in and that effort multiplies, and the value that we all get out of it is really a positive feedback cycle. So this sort of, think of openness as kind of a sort of nutrition. So basic nutrition fosters collaborative engineering and co-innovation, unleashing creativity and creative solutions that can be shared by everyone. And so let me illustrate this by sharing a few examples. Last year at Intel Innovation, we briefly talked about Infrastructure Programmer Development Kit, IPDK, which is a piece of software that we can run on an IPU, a SmartNIC, to basically offload processing from the CPU and memory to that SmartNIC device. And it's an open source vendor agnostic framework that delivers APIs and drivers for infrastructure offload and management that runs on a CPU, an IPU, or even a network switch. And IPDK.io is a project created on GitHub by Intel, and the team recently announced the first release of IPDK. We've been working really hard on this for at least the last year that I've been in the company. In addition, Intel and other industry leaders are launching together something called the Open Programmable Infrastructure Project. We launched this in June. OPI is addressing the need for a common open framework for programming infrastructure applications. So IPDK is the first project to move into OPI. Its industry's leading contributions help further our vision for open, vendor-agnostic frameworks, drivers, and APIs. It runs on other people's GPUs. For infrastructure offload and management, again, this frees up capacity on the CPU and memory by pushing it down onto the network layer. So there's lots of cases where this is useful. One case is Intel also created an open storage performance kit, development kit called SPDK. Many of you are familiar with and have probably used DPDK. I've been using it since my days at Cisco, and to enable high performance and extensible data path optimizations for the NVMe storage protocol, classic offload use case. And Intel has leveraged SPDK and our IPU storage acceleration. And today we have over 60 companies that are contributing to SPDK to basically enable that open source storage protocol to be widely deployed across data centers, et cetera. So we're using the same open source approach that we use for IPDK, SPDK, and DPDK to enable AI and ML developers by upstreaming code for Intel's hardware accelerators, some of which you'll hear about in a minute, for popular AI frameworks such as TensorFlow, PyTorch, OpenVINO, and we have these running across our CPUs and now our Arctic Sound GPU and many others. So TensorFlow 2.9 was released in May of this year, and this is an important release because Intel had put its one API, one DNN, that's our deep neural network technology, into those ecosystems, into TensorFlow in particularly, and so now when you just download it, and there have been over 10 million downloads of that version, it just automatically accelerates and works on Intel processors, including the ones we haven't yet released, but we'll have available in our Intel Developer Cloud, which I'll talk about in a minute. So there have been over, we also released TensorFlow 2.10 was recently released, and Intel has also taken full ownership of developing the accelerator code inside TensorFlow for the CPU running Microsoft Windows. So we actually do the release and packaging for TensorFlow for Windows to optimize and accelerate that. And we're also working with Google as a founding member and contributor to the OpenXLA project. If you haven't heard about it, I recommend you go look it up. It's going to be really fundamentally transformational in the way that we make sure that when you write your AI ML code, you can compile it and run it everywhere and not be sort of restricted to a particular kind of device. And this helps standardize an open source modular community-built compiler technologies, for example, like LLVM, that project helps accelerate machine learning and development across multiple hardware backends. And I'll talk a little bit more about this in a minute. So now for my next topic, I want to sort of transition a little bit to a little bit retrospective, but to set a foundation for the future. I began programming and teaching when I was a professor at the University of Texas at Austin in 1994. It was the first object-oriented programming class that was taught at the university, and I used Java, which was relatively new at that time. And I also spent 10 years at Sun Microsystems after my university days. I think we can all agree that the contributions to our open source community have benefited from the work that was done in the Java ecosystem, particularly the JSR process for standardizing and evolving the standards to make sure that Java didn't fork into the Microsoft version, the Sun version, the IBM version, et cetera, where you had this sort of distribution. So we had sort of this single common programming language that could write once, run everywhere. And that's a really key concept, and that was fundamentally a groundbreaking change to what Java created. So, but rather than hear from me, please welcome my former Sun Microsystems colleague, industry Illuminati, James Gosling, who will be joining us remotely. James, first, thank you for wearing my Open.Intel t-shirt I sent to you. So basically, you know, kind of the basic sort of thing I want to sort of set up here with James is that.
Hi there.
Oh, there. Yeah. We forgot to look.
You know,
Yes, James. I want to say thank you for wearing the T-shirt I sent you.
Oh, you're most welcome.
Yeah, because I think it's sort of we sort of branded it this little logo, but ultimately I think you and Linus together are really two of the people that are sort of my sort of heroes with regard to the fact that you lived it and breathed it and created it and brought us to this day, and I think that's the real story. The thing I wanted to sort of I'm curious. I want to get your opinion on something. So I've been developing software for a long time, and up until the time at which Java came about, I mean, I had to sort of take my source code, whether it's usually C or C++. I'm sort of I'm a networking protocols engineer, and I would have to write my version for Sun OS, then Solaris, and I would have to sort of if-def my code to let it run on a Spark architecture, and I had to know that the system call interface before POSIX standardization happened. I had to know which system call libraries to use and particularities about the hardware architecture, because RISC is different. Then I had to do the same thing for AIX on Power. I had to do the same thing for the DEC OSF1 on the Alpha, and then I had to sort of on the Windows environment, I had to sort of do a lot more work to map my sort of Unix code over to Windows and get it running properly on Windows for x86, and And then if I put it on Mac OS, I had to deal with initially the Motorola 68000 series, then they switched to the PowerPC, then they switched to Intel, now they switched to ARM. So you're always sort of chasing, changing your code to do all this. But Java just sort of like took all that headache away from me as a software engineer and really just said, okay, I can write my code once and I could run it everywhere. I maybe had to do some testing, to kind of make sure that everything worked correctly. But that was sort of the fundamental change. And it was open, and there was a standards process for how things evolved. So you could just talk about like how that came about and the importance of having that kind of abstraction so that we don't get tied down and too much into the hardware peculiarities, but we get all the performance anyway, because you have this JIT compiler that mapped all that code to the underlying architecture without me having to worry about it as a software developer. So given that kind of framework, kind of give us some advice for the future.
Well, I mean, it goes in a number of different directions, right? You talked about going between, different hardware architectures, but, even within an architecture, there are flavors, right? People will, typically compile their program. If you're writing a C program, you compile it for x86 for Intel, but the different chipsets from Intel, the different generations, the optimizations are slightly different. And most people don't bother doing that because there are too many. Occasionally people will do that. The nice thing about something like the JVM is that it does that by magic. But the really exciting thing for me in some of this stuff is to be able to build software for systems that have not been invented yet. One of my standard test programs is a solitaire game that I wrote decades ago. It's a Java program, and it still runs everywhere. It runs on machines that people hadn't even dreamed of when it was written.
Yeah, so today we're faced with, and we just announced our sort of two GPUs, a sort of a gaming GPU, and then we also have our data center GPU. We call it Ponte Vecchio. Arctic Sound is also our inferencing GPU and media streaming GPU. And my team, works with the GPU team to get software ready and prepared and running, for Windows, Linux, et cetera, across these GPUs. And we have the brain power, we have the expertise to kind of deal with the low-level hardware interfaces and try and build that up. And what's nice about it, I mentioned PyTorch and TensorFlow and OpenVINO, it just runs. You don't have to go tweak it, you don't have to go change it, stuff like that. And we use our one API compiler basically to optimize and compile that code using, it's an LLVM-based compiler, and that gives us the ability using an open source intermediate representation, the intermediate representation that we compile to, and then we map it down specifically with the knowledge of a lower level compiler about how to accelerate on that particular hardware. But we don't have in the industry today an open sort of programming language, an open programming model that says, okay, well, I'll write my AI code or my low-level AI code, we'll write it once and run it everywhere. What we have is sort of more of a proprietary stack that you have to pay and use that proprietary stack. And we could do the same thing for open accelerated computing, GPU programming, by basically having a kind of an abstraction layer, much like we did with the JVM, but doesn't give up any efficiency and compiles to that diverse heterogeneous set of hardware accelerators. They're not just GPUs, there's AI processors, et cetera, FPGAs. So what are your thoughts about where we as an industry should go in terms of what I call open accelerated computing?
Well, so one of the sort of folk principles at Sun years and years ago was that it doesn't matter how many employees you have, there are always smarter people outside your company. And with things like these foundational pieces of software for doing ML or whatever, really, you get a lot more horsepower if you can get collaboration across the industries, across academia. It's really about enabling collaboration, and it's both innovation, and it's also understanding your customers' needs. A lot of times people, at an engineering organization like Amazon, where I am, or at Intel, you have your own kind of mental view of what customers need, and you try to make that as close to what real customers need, but it's never quite right. But if you actually get customers involved in the process, then suddenly you find that you really do meet customer needs, and the customers can say, no, this is not right, that this would be better that way, and you can do it, or the customer can do it, and they can submit it and submit a pull request, and the whole process accelerates and gets smoother, gets deeper, and it just works better for everybody.
Yeah, thanks. So one final thing, I think too, when you try and do open efforts, just that we lost your audio again.
Did you?
Yeah, go ahead. We hear you now. Go ahead. Just say what you just said.
I didn't. I'm not sure which piece you missed.
Okay, well, that's right. Well, let me just ask you one more question, because I think we're about out of time for this session. But the other key innovation was not the software; it was JSR.
Yes, the Java specification requests.
Yeah. So that really
helped.
That really helped. Like, people didn't go fork Java, so you had like 6 different versions of Java depending on which piece of hardware you had. So can you talk a little bit about why it's important to have open governance, not just open source?
Yeah, so one of the interesting things about the open source movement these days is that there are several general categories of camps, right? There's the Apache camp, there's the kernel.org camp. There's several of them. And one of the things that they all have in common is a process, and the process is about how you request features, how you report bugs, how you make a contribution, right? So things like, what, the JSRs in the Java world now turn into pull requests, right? And a pull request is a technological trigger to a debate. And, through the pull request process, things get accepted or rejected, and then the whole evolution is very managed.
Okay, James, thanks very much. I really appreciate all of your insights. It's great to see you. By the way, I haven't seen you in a while, obviously, since we were together at Sun Microsystems. And I wish you well, and I'm so glad you're still productively contributing and helping move this industry forward, because we need your kind of leadership.
Yeah, well, I wish I was there.
Okay.
Yeah.
James unsupervised. So. All right,
Okay.
so also I have our latest Dragon Canyon NUC that I'm going to give ship to James. I have one of these myself. I did the complete teardown when I first got it out of the box. It's a master at thermal and mechanical engineering to get that much compute power in a small form factor. That's the Intel Canyon Dragon NUC 12X Pro, or Pro X. It's like got the i9 Alder Lake processor in it. It absolutely screams. And we'll be talking about that a little bit more later. So anyway, so thank you, James, and we'll ship it to you, or I'll hand deliver it to your house. How about that? Once you recover from your cold. So anyway, James will also be hosting a session later today entitled "The Open Source for Skeptics." And if you're here in person, I encourage you to check it out. It'll be by video, of course. I'm in the open source ecosystem sharing mood after hearing from James. So how about we throw out a few of these Open.Intel t-shirts to the audience? I got some t-shirt tossers, running up and down the aisles there. Don't forget the right side over there. I don't want people fighting over them when they go out the door. It pays to sit closer to the front of the room.
What it's all about. Well, I know what you're feeling right now. It's true, it's true. If it's so,
with that tee up and built on what James was talking about, I want to talk a little bit more about this idea of open accelerated computing and what does it mean, and both why it is and why it's important, because I think this is really important for the industry. And I think Intel, again, we want to take a leadership in promoting open source technology, open standards, and open process so that the whole industry benefits. And then we'll compete with everybody at the hardware level, but let's not penalize people at the software level. We need an enriched, powerful software ecosystem that everybody can use seamlessly. And as I said a minute ago, 90% of developers today are using Intel accelerated technology. They don't even know it, and that's the way it should be. So in some ways, we are lifting a page from James's playbook for Java. That's what inspired me to kind of have him come and talk to us. Where the big breakthrough was enabling developers to write once, run anywhere, without having to change that low-level code. So open accelerated computing's goal is to do the same for hardware accelerators, lifting developers out of the proprietary approaches like CUDA and enabling them to write once with open source tools, and there happens to be one called SYCL, S-Y-C-L. It's sponsored by the Kronos Group. It's up for standardization in the ISO C++ standards process. It's just C++ code that's been enhanced with capabilities for data parallel programming on GPUs, other kinds of hardware accelerators, and we even run it on our Agilex FPGAs. And this allows us to basically have one piece of source code that you compile in the compiler and the runtime layers underneath it, like LLVM, do all the clever working, just like a Java JVM and a JIT compiler to optimize it for the lowest level hardware. And so every hardware vendor can optimize the low level drivers and the runtimes for their devices, and then the compiler can compile it down to that level. And our one API compiler today, which we call ICX, today does this. It takes SYCL source code, which is just C++, and we use the LLVM compiler ecosystem and an open source intermediate language to generate code for our own GPUs, our CPUs, and our FPGAs. And we can do it even for other people's hardware devices. And this creates choice for developers. So anyway, so to further this goal, as I came into Intel 15 months ago, Pat asked me to join, is I started thinking, okay, well, so how do we do this? How do we foster this new open way of programming hardware accelerators that create open accelerated computing? So I looked around the industry, talked to a lot of people, and I discovered there's this brilliant set of 85 plus engineers based in Edinburgh, Scotland, and a company called Codeplay, which you probably never heard of. And this company, led by the CEO, Andrew, has been doing this for about 20 years, mostly in the HPC community, because the high performance computing community are big supporters of open source and just getting the job done on high performance computing, and they've been our customers for many decades. And so we acquired Codeplay, but we did something very unique. We kept them separate as an independent managed subsidiary, so they're not Intel employees, and we motivate them to basically broaden the ecosystem. They work closely with the Kronos Group on a standardization of SYCL, helping drive the standardization process through the C++ standards body. And they've been developing heterogeneous accelerated computing software for a long time. And we've passed over the one API specification, as I talked about the JSR standardization process, to them as an independent party to help drive it across the industry and get everybody to adopt it. So this is really trying to, and we even have support for, one API has support for AMD GPUs, NVIDIA GPUs, as well as SYCL on RISC-V. So we support those additional accelerator technologies, not just our CPU and our GPU. This is fundamentally important and really goes to the heart of what I mean by open.intel. And so further, we want to just do this because we can be hardware agnostic, multi-vendor solutions, and our one API specification will be out there to support the broader community and have this play across everything. Yesterday, Pat talked a bit about one API, which is another good example of open accelerated computing, as I just mentioned. It's cross-platform, standards-based. It delivers a common developer experience across the processor and accelerator architectures. And as I said, at the lowest layer, it relies on the compiler ecosystem that everybody's using, and OpenXLA is using LLVM. So this really gives us a solid foundation. And then you let all the creativity be at the model development level, right? The inference training and tuning level, and get wide deployment and bring in ethical AI, as we've talked about. Nama Nachman gave a recorded session about this. And this provides essentially a way for developers to choose the best architecture to solve a specific problem, and that without rewriting a bunch of software to basically tweak and tune this, that, and the other, This should all be handled by the underlying runtime, the underlying drivers, the underlying optimizations that each hardware vendor can bring and support a single common standard programming language. And by the way, there are 11 million C++ developers out there. Just makes it, democratize it for them. So, beginning this December, we'll start shipping 2023 versions of Intel's One API toolkits. It's a collection of 42 different tools. These toolkits fully support the Intel 4th generation scalable Xeon processors, codenamed Sapphire Rapids, and as well as our data center and ARC GPUs and Agilex FPGAs. It's already there. We'll start shipping those in January. We already have the support today, but we'll be shipping the 2023 versions of what we have. The 2022.3, the third quarter release, will be available shortly, which incorporates updates to all of our other 2022 toolkits in that release. So you can start developing today with One API toolkits, download them for free, access them via your favorite repository, and please join us at the Tech Showcase for one of the several technical sessions being showed that demonstrate the full set of One API tools in action, optimizing performance for our latest processors, and how to migrate CUDA code, source code, automatically into the SYCL C++ language. We call that Cyclomatic, so it's like a machine, washing machine, that'll wash it from proprietary to open. And this Intel Innovation app that's on your phone, hopefully, has all the information that you need for those various sessions. In addition to some of the open source projects and tools I have talked about today, we've made significant investments in each software layer over decades to build a vibrant ecosystem that allows developers to create and realize value throughout multiple layers of the hardware stack, including our boot code is open source. So value can be realized from hardware up through all layers of the software stack. And so our goal is to make it easy for developers to get all the value of the thousands of engineers I have working in firmware, BIOS, operating systems, virtualization layer, right? That we have the expertise and the breadth and depth of skills to do really, really well. And then you just take advantage of it for what you're trying to do. And so it's really that open source ecosystem that we've delivered, and we deliver in every product that we ship. Now let's look at the different levels of what I call software value realization, because this is the way we think about software at Intel, is we make this big investment, and Pat referred to it as what I call it, the soul of the machine, the software that brings up the hardware, brings the hardware to life. And that's basically that lowest layer we call the market enabling or foundational software layer. And that allows us to ship our CPUs, GPUs, FPGAs, smart NICs, out into the world and let people start using them and being productive using things like IPDK I mentioned. And so I have a lot of people that are expertise at this, and this is what we do every single day and to get this technology ready for the market. And then if we go to the next layer is where things get interesting. It's that whole open source ecosystem I've been talking about. It's like, like Java, like Python. I mentioned PyTorch, TensorFlow, OpenVINO. There's just tremendous thousands of systems, software libraries, runtimes, Kafka, MySQL, you name it. It's all there. We optimize all that code for you. And so I have a bunch of software developers. We have a bunch of software developers in the company that just do this every day, and we work with key ISVs as well, which is not open source, to make sure that they leverage all that advantages. And they consume a lot of open source too. It's in their products, you just don't know it. And so really this idea of building these sort of value layers, market enabling hardware, foundational software, the middleware stacks, languages, frameworks, and tools, to kind of get to the next layer of market differentiating technology. And once we get past that layer, we now move up to what I call the market making layer. And that's where we leverage all that optimization that we've done in those lower two layers to really pull through new value through software as a service and subscription capabilities. Project Amber, which we announced at Intel Vision, is essentially one example of that. We have this confidential computing hardware, software guard extensions. At the hardware layer, we have a bunch of firmware and BIOS software that sort of manages that. And we have an open source library that Pat mentioned in his slides called Grammy that runs in that middleware layer that glues your application, relatively low code, and matches it down to that hardware capability and allows you to store your secrets from your application down into the hardware. But how do you know that it hasn't been tampered with? How do you know that some cloud vendor is not poking in there? You have the ability to do our attestation service, which is what Project Amber is delivering, that will attest to the authenticity of the CPU through the CPU ID to make sure that the firmware has not been tampered with. We digitally sign it, we encrypt it. Same with the BIOS, so that you know that that machine in the cloud that you booted, that has a hypervisor, that has infrastructure as a service and containers as a service and platform as a service, that you know that that has not been tampered with. And I think of it like this: you're the application, and we're giving you a titanium straw that you could slice through all those layers of stack, and you could touch the hardware and store your secrets in that trusted execution environment, and only your application has the ability to access it. As a former CTO for Citibank, this is really important in banking, is to make sure that third parties don't have the ability through malicious insiders to tap into your secrets when you're running in the cloud. And so this is a fundamental technology that Intel's been developing for years, and now we have the full stack capability to make that important. And the place where it's going to be the most important is in AI ML models, particularly at the edge, to make sure that when you're running a model at the edge, it's not being pilfered, it's not being stolen, it's not being manipulated. Your parameters that you spend $1 million training on basically are protected. So this really is what Project Amber is really trying to do. Now, well, don't hear it from me. I want to sort of talk about how we can do this in the healthcare industry. So I'm thrilled to have the president of Leidos Health Group join me today to share how they are using Project Amber with confidential computing as I just described. Please welcome Liz Porter from Leidos.
Thank you. Hello, everyone. I am excited to be here at Intel Innovation to share how Leidos and Intel are collaborating to protect patient data. You probably don't realize, but more people in the United States and in other parts of the world have own mobile devices than actually have access to healthcare. Apart from affordability and other limiting factors, having access to timely healthcare, especially in remote areas, is important to achieve the best health outcomes. QTC, a Leidos company, operates mobile medical clinics that deliver high-quality medical examination services in rural areas and underserved areas of the United States. Patient care relies on medical professionals having cross-platform access to real-time data from wearables to medical devices for diagnosis. Securing both digital and physical systems in healthcare is a challenge. Devices must adhere to stringent certification and policies while actually maintaining function in a medical capacity. Leidos is responsible for protecting patient data confidentiality, integrity, and availability. Confidential computing defends sensitive data in applications from insider threat and cloud-based attacks. Project Amber creates a new opportunity to approve attestation of edge-to-cloud infrastructure. Intel and Leidos are piloting the Project Amber attestation service with Intel SGX on Intel third-generation Xeon platforms for future use in our mobile medical clinics. Our clinical staff performs medical exams and processes health information for our U.S. military veterans. Given the sensitivity of the personal health information, security would be enhanced by encrypting data while in process, not just in transit or at rest. This pilot examines the cybersecurity, performance, scalability, and flexibility of Project Amber, supporting a zero-trust architecture. As a recognized leader in cybersecurity across the federal government, with advanced capabilities honed from safeguarding some of the world's most valuable assets, Leidos produces solutions and services for a robust security posture. Project Amber's independent attestation service makes it possible to scale and move workloads across a wider range of edge, on-premise, and cloud environments. This liberates Leidos to focus not to focus on the need to build and maintain complex and expensive attestation systems, but to be able to focus on our core differentiation in intelligent automation and AI/ML-driven analytics. Gregg, thank you for the ongoing partnership. It is with this new collaboration that Leidos and Intel will be safeguarding our customers' missions. So thank you.
Well, thank you very much. Leidos also works with us, with their red team, to try to hack our Project Amber service to make sure that we got the robustness that's required for your applications and other applications by the U.S. government. So thank you very much for your partnership.
Thank you.
Now, we have several other. We have other beta customers involved in Project Amber across different industry verticals, not just healthcare, to really kind of get a broad perspective on that. And Amber itself runs as a confidential computing application using our Secure Guard extensions to secure itself. And that's a really key attribute of making that service available with the highest degree of integrity and computational computing you can have. Now let me shift topics again and talk a little bit about AI everywhere, which has the potential to transform every industry by accelerating the conversion of massive amounts and growing amounts of data into actionable insights. This is the challenge, not just the AI algorithms and doing large models that we hear about, that's sort of the really top end of the breaking the curve, but really the everyday computing using data and massaging data, making sure the data quality, preparing the data for training, and then using it in inferencing. And is evolving it, as we've seen with the Pat's demo, sort of fine-tuning that learning algorithm with tagging to make sure that you're picking out the right elements of a particular, let's say in this case, a visual model. So AI workloads are the most demanding workloads that we're now seeing. With our 4th generation Xeon processor, we have a number of accelerators that help not just to optimize the matrix math that we have to do, the advanced matrix extensions, but also the data processing extension accelerators. So these workloads require both of those things to work together. Whether you're doing it on a CPU or whether you're doing it on a GPU, data becomes the dominant aspect of what you have to manage at scale in order to have effective AI. So many of these leaps that we're working on are dependent on the AI open source ecosystem, and we're building these scalable data and software platforms powered by our one API programming model and toolkits delivering openness, productivity, and performance, and security, when you bring the computational computing piece together, to make AI more accessible and easy to use for the broadest range of developers and applications, and the latest security features, as I mentioned. So today, our joint efforts with Accenture, we are announcing the release of the 3rd set of AI additional reference kits. This is the 3 additional sets of AI reference kits for the healthcare industry that will help clinicians review medical code classifications, identify imaging anomalies, and facilitate claims reviews. This, again, healthcare is a dominant area where this is happening. These kits expand the reference kits that we've already released in July for a broad range of use cases, and all these kits are available as an on-ramp onto AI, and it's all available for download from GitHub. So you can go there and check, and every month we'll be updating these kits. So on Monday, we held an AI for Social Good hackathon. You may or may not have participated in it. We had over 100 teams that were working to solve sort of like social good problems for AI, and using these AI reference kits, in which teams, they use these toolkits to optimize and solve 3 completely new AI problems across natural language processing, computer vision, and classical machine learning in under 12 hours. It was quite a show. And we had 2 winners that were part of that team, and the hackathon winners happened to be students at San Jose State University here in the Bay Area, and they're now the proud owners of a coveted Intel NUC. I sort of jokingly told them we're going to give them 1, they had to cut it in half and share it, but we actually gave them 2. You should have seen the looks on their faces when I presented the Intel NUCs to them. They said, we can't even get a good laptop at the university to run our stuff on, and we can't afford to go pay for Amazon's cloud, so they've got a cloud in a box, basically, right here with our Alder Lake 9th Alder Lake processor. Okay, since we're speaking about AI everywhere, and we're also collaborating across ecosystems to enable hybrid cloud architectures, including AI at the edge, let us hear about some of these new developments from Red Hat CTO and my friend and Senior Vice President of Global Engineering at Red Hat, Chris Wright.
Thanks, Greg. Red Hat and Intel have a long history of collaboration and building open ecosystems. Our goal is to make it easy to develop and deploy in open hybrid cloud architectures. On that note, I'm joined by Sudhir Srinivasan, SVP of Multi-Cloud and Data Solutions from Dell, to highlight our latest joint efforts to accelerate DevOps in hybrid cloud environments, all powered by Intel.
Thank you, Chris. Our collaboration is key to giving our joint customers more flexibility and choice as they deploy new applications and even modernize existing ones in multi-cloud environments. Together, we announced joint solutions and a commitment to co-engineer a unique hybrid cloud solution powered by Intel. This automated solution will use Dell software for full stack integration of Red Hat OpenShift on Dell software-defined infrastructure, making it easier for our customers to build applications once and run them anywhere with a common operating model. I'm also pleased to announce the availability of our Dell validated platform for Red Hat OpenShift, which is a solution that streamlines deployment of on-premises infrastructure for container orchestration. For those at Innovation 2022, please check out the demo in Dell's booth. Back to you, Chris.
Well, thanks for joining me, Sudhir. Our vision of AI, ML, and edge compute is exemplified by our work with Intel. Last year, we launched Red Hat OpenShift Data Science. This is a cloud service which we've integrated with Intel's AI portfolio so developers can train and deploy their models using Intel's AI Kit and OpenVINO. Now we are working with Habana, an Intel company, to make their Gaudi deep learning accelerator available on OpenShift Data Science. This combination delivers cost-efficient, high-performance, deep learning, model training, and deployment, all as a managed cloud service. And we are extending OpenShift Data Science's enterprise MLOps capabilities through the integration of Intel's Converge.io. Lastly, for developers in the realm of AI, ML, and Edge, we're launching Intel and Red Hat's joint AI developer program. The program helps developers easily learn, test, and deploy models using OpenShift Data Science and Intel's integrated AI and Edge portfolio. Developers can get started today on the Red Hat and Intel developer zones. Back to you, Gregg.
Thanks, Chris. It's a great partnership. It's a great partnership between Dell, Intel, and Red Hat. In fact, after the show, I'm flying to Austin. I work closely with this Office of CTO at Dell for all-day meetings tomorrow with our Gardar partnership and collaboration across many other things besides this one. Just want to emphasize, again, you think about this edge computing. Our Xeon D processors have our software guard extensions in them. And in the sort of the manufacturing edge, that's where these get deployed a lot because, again, it's outside the security perimeter of the data center and the usual security controls. So confidential computing for the models at the edge, managed capabilities like they're talking about here, it really brings a partnership together of leading companies that can deliver this uniquely to the market. So as AI becomes more pervasive, there's one industry that has an enormous potential benefit to really change things, just like what we hear from Leidos, and that's life sciences, fundamental science and biomedical engineering and capabilities. So the opportunity for AI to transform drug discovery, discover diagnosis and treatment capabilities that are largely dependent on our ability to process data effectively, and to build and deploy these AI models efficiently and securely wherever they go. So I'm pleased to invite the head of AI Research and Development and Information Research at OBV to join me through their experience collaborating with Intel and a startup company that we work closely with called Katana Graph to build an optimized AI pipeline for drug discovery on the Intel Xeon scalable platform. Please welcome Mr. Brian Martin.
All right, thanks, Matt. Thanks, Gregg. At AbbVie, we take on the toughest health challenges. But we do more than simply treat disease. We aim to make a remarkable impact on the lives of patients. And we're relentless in the pursuit of insights into human biology and the human condition. Biopharma R&D has a productivity problem. Knowledge and data are expanding at exponential rates, but productivities remain relatively flat, even considering this. A single drug usually takes multiple billions of dollars and over a decade of research and development before a single patient is able to get that prescription at a pharmacy. We've set a target to double R&D productivity. That means finding ways to leverage knowledge to deliver increasingly accurate predictions, deriving insights rapidly to accelerate hypothesis testing, and utilizing automation to better scale and amplify the work and the research we're doing. But nothing can replace the empirical testing in a lab. And so the increasing use of in silico methods and data-driven prioritization is really about getting higher levels of resource accuracy and precision in what we're doing to enable those resources in the lab to work on the most critical projects. Knowledge graphs give us the power to aggregate, integrate, and harmonize knowledge into a fabric of shared understanding. But building these graphs relies on our ability to ingest, harmonize, and curate massive amounts of internal and external data, and connecting information about molecules with assay results, with clinical data, with real-world evidence and data. It gives us the ability to connect opportunities with outcomes But mining these graphs requires accelerated data analytics capabilities. Simple subgraph pattern analysis has already helped us to find new possibilities for patients with extremely rare, think a prevalence of 2 in a million diseases. But we want to be able to leverage that knowledge to help millions of patients and thousands of different diseases. Leveraging the knowledge has also helped us build better models for predicting chemical outputs like toxicity and metabolism and other important characteristics of the molecules before we even take them into the lab. Building these graph neural network models with sufficient precision and accuracy takes significant efforts to train and deploy. Ultimately, we need platforms like the Intel Data and AI platform and Katana Graph Intelligence platform to enable this type of research at scale. Platforms that are easy to use, they're performant on end-to-end graph workflows, and speeding up the data to insights journey. This combines ultra-high capacity data ingestion, flexible on-demand storage, and high-performance computing to enable us to perform graph analytics and AI ML on just drastic scale data sets. Through our collaboration with Intel and Katana, we see the potential of such advances as the 4th generation Xeon scalable processors, with especially the advanced matrix extensions to test out these various solutions before we make the decision to invest in bringing these resources into our labs and into our compute facilities. And the Katana team working hand in hand with the Intel team, using the 4th generation Intel Xeon scalable processors, we're able to deliver 16x speedups on distributed graph partitioning and 4.7x speedups on distributed GNN training through the use of Intel AMX and bfloat 16 precision. This shows us the power of combining the next generation hardware and software together. Ultimately, through innovative collaboration, we're able to deliver deep insights on connected knowledge at lightning speed. And with it, we're revolutionizing the drug discovery and development process and saving lives.
Thank you, Brian. Wonderful. Thank you.
Thank you, Greg.
Okay, so basically, this is a great example of using Intel One API, our graph neural network, One GNN, right, which has open interfaces to allow Katana Graph to integrate to get the value out of that technology, again, to solve real-world problems like you've seen today. So yesterday, Pat stole some of my thunder about Intel Developer Cloud, but now I'm going to actually just show it to you because I can't keep it a secret any longer. So I would like to welcome Harman Vanderlyn on stage to take us through it. Harman's the senior product manager for Intel Developer Cloud. Thank you, Harman.
Hey, guys.
Thanks.
Thank you. I'd like to join, I have David here on stage as well to help me with the demo. So thank you, David. So during the past couple of months, we invited a small number of customers to participate in a small Intel Developer Cloud trial with a lot of success, actually. And we got a lot of great feedback. So as a result, we decided that we're going to expand the beta trial, make Intel Developer Cloud available for more customers and more developers. So let's have a look at it. So what you see here is the landing page. It's the landing page, it's cloudintel.com. So that's the starting point. This is the typical activities for users to register, to get an account. And if we scroll down in this page, you'll see these different services that we are planning for Intel Developer Cloud. Some of it we will see in the upcoming demos. It's very interesting stuff. For the beta trial, we're going to first focus on the early technology access. So the goal of these services is to provide early access to pre-release hardware, Intel hardware and software. It's primarily for developing and certification testing. So let's have a look at the different platforms that are available in the current beta trial. To do that, we go to the service catalog page. So in a nutshell, there are 4 different platforms that we're making available for users. So the first category is mostly focused on developers. So we have different virtual machines available, different sizes of virtual machines. But we also have dedicated bare metal systems as well. In both cases, These platforms are supported by the latest 4th generation Xeon processors. You heard the announcement about the GPUs yesterday from Pat, but guess what? We have these GPUs also available in Intel Developer Cloud. So we have the Flex series, the ATSM cards, and we also have the Ponte Vecchio GPU cards as well. And finally, we also make available AI accelerated systems with the Habana Gaudi training processors.
So how many cores? Well, I can't read that, my glasses are trifocals. How many cores do I have per VM?
Yeah, Greg, so we're starting, and I'm pretty sure this will evolve, but we're starting with 4 different form factors. So we have 4 cores, 8 cores, 16, and 30 cores, 32 cores.
Okay. So I can do some real computing, this is not a toy.
Correct.
So how do I provision these platforms? I mean, do I have to like SSH in, spend 3 hours configuring everything? I mean, or is this more push button?
You're right on, Greg. That is the typical way, the way you need to set up new platforms, assuming you can get access, can get hands on it. So users of Intel Developer Cloud, they can reserve a platform for a specific amount of time. And the starting point is the cloud management portal, cloud management console, I should say. So you see these different platforms that you can order. And when you click on it, basically there's a registration process. And then to spin up any of these machines will typically takes anywhere between 1 to a few minutes at the most. Now keep in mind, there's no installation, there's no configuration, and there's no software download needed. You can start right away. Now also, as a note, this is a beta trial, right? We've seen already a pent-up demand. A lot of people are very interested, and we are working very hard to build out our cloud infrastructure. So could be very well the first couple of months that we cannot support everyone at the same time. Also, we're working with sales and field teams right now to identify customers that we want to invite to participate in this trial. And there's also more to come, obviously, in the future. So I want to leave you with some feedback from the initial trial customers. There's a lot to read here, but what's really interesting is to see the different ways how these companies have been using Intel Developer Cloud. And I want to point out one company. This is the MySci Labs company. So this is, as a matter of fact, this is a Converge.io MetaCloud customer. So Converge.io is an ML ops service that allows customers to deploy ML container workloads in different clouds. So now, in addition to the cloud portal, so cloudintel.com, Intel Developer Cloud is also available through the Converge.io offering. If you want to learn more, there's a session coming up after, later this morning as well. So I encourage you to attend that session as well. Greg?
Thanks, Harman. I really appreciate that. It's a major step in our evolution of both software and hardware, bringing it to the developers, again, by developers, for developers, so you can take advantage and harness these future opportunities before they show up in a server or cloud vendor of your choice. And it gives you early access to Intel's latest hardware products for performance benchmarking.
Thank you.
Which, by the way, is really the key thing, right? We have all these hardware accelerators, we got these new knobs you can turn, but it's complicated. So, you know, what the next step is then, okay, how can we help you basically get that performance tuning and that performance optimization going? So, as developers, we want to get to the details of that, and I'm going to bring on a world-class leading expert who's been doing this for decades. I worked with him together at Sun Microsystems. He was the lead performance engineer at Netflix. It took me 6 months to recruit him to come over to Intel. I had to have Pat call him to push him over the edge. And so welcome all the way from Sydney, Australia, the creator of eBPF, Extended Berkeley Packet Filter, Brendan Gregg. I'll speak Australian. Good day, Brendan.
G'day, and g'day everyone. To ensure that Intel's products provide industry-leading performance in the cloud, we need the best tools to help us to thoroughly understand performance and to identify where to tune, optimize, and innovate. Our customers also need the best observability tools as well to get the most out of Intel systems. It's my dream to be able to observe everything, to understand the performance of all software and hardware. We have many capabilities planned in this space, and the first we've been developing is a continuous open source profiler as a service. I'd like to demonstrate 3 profiling capabilities from this service and explain why they are important. The first is CPU flame graphs. Many of you may already be using these. They have become the staple for performance observability in the industry. And this visualization shows you the shape of the software that you're running. It answers questions big and small. I can zoom into details and see the width here is not the passage of time, but it's showing how much time you're spending using CPU resources for this CPU flame graph. And I can go through the code and answer questions. I can also search for things. So I'm going to search for join. This example here is the MySQL database. And it's highlighted the code that's in join. And in the bottom right, it says that's matched 28.6%. So this is CPU flame graphs. You might be familiar with it. Really useful capability. As a performance engineer, it's not so much about finding a performance issue. It's finding the performance issue that matters. And so being able to quantify things immediately helps me select what matters. These CPU flame graphs also show all layers of the software stack, from the application code down to the kernel code and down to metal, so that you have the full picture. I invented these over a decade ago, and they are now the standard visualization for understanding profiles, and are supported by many different profilers, including Intel vTune and gProfiler. At Intel, we're using new kernel technology, eBPF, and I pioneered eBPF for observability use cases to make the collection of these more efficient, along with new instruction level optimizations. The second capability is off-CPU flame graphs, which we are going to include in a public product for the first time. This is the companion to CPU flame graphs, as it shows performance when you are not on CPU, when it's the time blocked on I/O, locks, the scheduler, and other events. Again, it's MySQL, and these are collected on the Intel Developer Cloud, and I can see these towers. This time, we discover that a lot of the time threads are waiting for work. They're polling. And this tower in the middle is most interesting. If I zoom in, this is during a MySQL request. And the width is, now it's the time you're blocked that's creating latency. And I can zoom in and find out exactly why. So here, this tower, I'm going through the MySQL code. I'm doing fsync, I go into the kernel, it's in ext4. This is amazing stuff. And it tells me straight away the microseconds of time for each of these different code paths. This is the companion to CPU flame graphs, which you may already be using. And this shows you the other half of the picture that so far for you may have been invisible. It's when you are not on CPU, here's all of the performance issues we can now explore and analyze. So together with CPU flame graphs, you now have a way to easily and quickly analyze the performance of all software and hardware. This one is also eBPF based. The third capability is CPI flame graphs. That's another visualization I've created, and we're now going to include in a public product for the first time. This takes CPU flame graphs and shows processor cycle performance, the cycles per instruction metric, as a color spectrum, from instruction bound as red to stall cycle bound as blue. So now I can see I've got this blue frame in here. If I zoom in, it's my hash sort simple. The blue is telling me that even though this was on CPU for a long time, it was stalled waiting for some other event. It wasn't retiring instructions. That's useful information for a developer because you can now do different actionable items to improve performance. It might be doing things like zero copy or other code patterns. It's also actionable items for operators because now when you're configuring the system and deciding what the system should be, you can optimize for memory performance as well. This is also great because it's bridging the gap between what developers understand, their source code, and then the internals of Intel processors and hardware by using that as a color spectrum. So this highlights developers' own code using these colors so that they can get down into the CPUs. And it leads to these actionable items when you know you have these types of hotspot. These flame graphs were generated on Sapphire Rapids on the Intel Developer Cloud, and we'll be making them easy to use in an upcoming service.
Thank you, Brendan.
Back to you, Greg.
If you had any doubt about the depth and breadth of experience we have at Intel to optimize everything, you just saw it, right? With the heat maps we're able to provide into every developer. We'll give some training courses. We got some YouTube videos, et cetera. So I know we're actually running a little over time, but I wanted to leave us with one final really cool demo about the future. The future will be here before we know it, and now's a great time to talk about quantum computing. There are several qubit technologies out there, but there's only one that's built on transistor technology, and that's the one Intel is focusing on. That's what we do. And our silicon spin qubit approach taps into Intel's deep know-how in how to develop transistor technologies and leverages our decades of experience in manufacturing transistors, and as Pat says, exploiting every element on the periodic chart when we need to go there. And so, the real thing is we're not there yet, but people have different theories about when we'll get to the quantum computing revolution, but we know it's coming, and we're doing this fundamental research. So let's see, what I want to do, let's go to the next slide. Our goal has always been to drive long-term research between Intel Labs and our component research team, and to get to large-scale commercial quantum computing implementation. And to achieve commercial relevance, these systems need to scale to over 1 million qubits to be really what we call, quantum efficient or quantum practicality. And so we want to get to that point. So what I'm going to show you is something ultra cool, a glimpse into the future. You saw it here first. This is a 300 millimeter wafer from our research lab. Let me see if I can zone in the light here to give you a sense of what you see. There's 10,000 quantum arrays on this 300 millimeter wafer. So this is a glimpse at the future. And so while this is, there you go, there's a really great shot of it. This is really ultra cool. And actually my first month in the company, I went up to the quantum computing research lab to see the actual thing in action because I was so excited by this part. And while this is cool, it's only good if the quality of the transistors and the efficacy of what we can get off of a yield is effective. Well, so turns out there's a tremendous amount of innovation going around just in the technology, not just to produce this, but to actually test it. Because you have to test it at 4 degrees Kelvin. So you don't want to stick your finger into the test lab. It'll immediately break off. We have something called Horse Ridge, which is we've miniaturized and can provide this test each quantum array with at 4 degrees Kelvin inside the test chamber itself, where you actually would run the quantum calculations. And before this, we had like half a room full of a kit, right, with a bunch of sort of cables having to go and transition from modern thermals to sub-Kelvin, 4 degrees Kelvin kernel cables, and sort of to test everything, which perturbs the environment. So this device actually sits inside the cryogenic chamber, so we can actually test every wafer, every chip on that wafer. So this in itself is a piece of innovation on which we patented. So anyway, so let's talk briefly about quantum computing software because I have my Intel NUC at home, and one of the things we're announcing today is our Quantum SDK for quantum simulation so that you developers can download the Quantum SDK. And this allows developers to program quantum algorithms using simulated qubits. The SDK consists of the Intel Quantum Compiler that's written in C++. So if you're a C++ programmer, when we talk about accelerated computing, you can sort of simulate what accelerated computing can look like. It's a standard LLVM-based runtime with quantum extensions. And we provide this you can run it on your laptop. And these elements create a full stack quantum computer in simulation. And let's take a look at it in operation. I'm just going to hit the return key here really quick so you can see on the screen sort of, where's the prompt? Okay, we've got a little demo glitch here. But basically, I could run the algorithm, and essentially what it will do is it'll generate 33 million states. And we have the ability to simulate that. So what I'm going to do, I've downloaded it on my Intel NUC at home, and oh, there it goes, it ran. So sorry, I was just a little bit late. I was a little bit impatient, actually. That's normal for me. When is it done? When's the code ready? When can we ship it? So So basically what we have is that I want to basically run the demo version, as I just did, run the algorithm, and finally you can see there are 2 resulting states. And this 25 quantum states gives you 33 million states. So I have a dog named Jeffrey, and ever since we've got him, he's a rescue dog. I mean, I'm just convinced that he's like an alien from another planet because he doesn't act like a dog. He just barks, he doesn't bark, he doesn't sort of act like a normal dog. So I'm working on a simulation for a quantum wormhole so I can teleport him back to his home planet. So before I finish talking about quantum computing, let's just touch briefly on security. I'm actually well over time, but basically, as we've been following the press, the NIST has been working to standardize quantum-resistant algorithms. They just announced, for symmetric crypto, some proposed algorithms. I mean, Intel's Ice Lake processor today and our future processors will support, we already support AES-256, which helps you with your data at rest problem to encrypt it so that if somebody takes it today, it's harder for them to decrypt it with a quantum computer in the future. But we really want to make our whole platform quantum resistant, quantum ready by well before 2030. So can't give you the specific dates of when that'll all happen, but we're working hard with NIST, we're working hard inside. We have the crypto experts. We've been a leader in this area forever. And so we'll make sure that all of our products are quantum resistant. And so President Biden made an announcement that, we want to get there by 2030. And so we're going to be ready, and we call it Pat calls it Y2Q. Okay, so we don't want the millennium bug problem. We don't want the quantum computing problem. So we're going to be Y2Q ready, quantum resistant by 2030 across our portfolio. And so I shared a lot of information today. As I said, open accelerated computing is a key topic for us to drive developer productivity and time to value. The open source ecosystem, our partnerships with Leidos, Obv, Dell, Red Hat, Accenture, many others in confidential computing and AI everywhere. It's real, it's here today, you can use it. And we'll look forward to you basically trying things out, join our Intel Developer Cloud prototype, our beta system. And we're ready to be here as your partner and help you accelerate what you want to do. If you're here in person, please take advantage of attending the many informative technical sessions, the showcase, workshops, and hand-on demonstrations for the rest of today. And you can access program information by the Intel Innovation app. It's been a real pleasure to actually talk to you.